Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over promises in JavaScript together. I've been itching to get to this video. It's one I'm super excited about. I can't wait to actually go over it with all of you. Promises are one of those things that are going to pop up again and again and again throughout the language as we learn JavaScript on the front end, on the back end, when we work with databases, in all sorts of contexts. They're basically a way to work with things that might happen in the future. Now this sounds pretty crazy, but there's a lot of constructs that we're going to learn to see how this might make sense and make programming easier for us. This is actually a form of what's called asynchronous programming, where we can work with things that happen in the future alongside with things that might happen kind of right now in the present. It turns out that pretty much every language actually has a construct to deal with this. They're just called promises in JavaScript. In other languages, they might be called something like futures or some other things. But it really does pop up absolutely everywhere throughout JavaScript, especially as you start working kind of across the stack. So that said, let's just get right into it and go kind of as far as we can with promises together. So to start, I just want to pose a question. I want to kind of you to go through this list of stuff. Now, it seems like a really arbitrary, random list of things. But my question is, how long do you think that these will take? Okay, these 6 different things. Now, when I say long, that seems kind of arbitrary, just approximately, like in the context of time specifically, like milliseconds, seconds, hours, days, months, etc. Okay, so let's go through each of these one at a time, and let's see if kind of what our answers might look like. And I promise you this does have a point when we actually get to the next slide. So for the first one, this is a pretty boring looking one, right? We want to loop 1,000 times, and each loop we want to kind of log something using console log to the screen. Okay, so this is kind of arbitrary, right? Is this going to take a short amount of time, a long amount of time? I'll make the argument that this is actually going to be very fast, right? If we do a loop and that loop is only doing one thing like this each time where we're console logging, it's probably going to be like less than a second, for example, right? Computers are pretty fast and they're going to be able to kind of crunch through this kind of programming task very quickly. So number one, I would say like maybe a second. Number 2, map over an array of 1 million items and add 5 to each item. So imagine it's an array of numbers, that's a million of these numbers, and we want to add 5 to every single one. So how long might that take? Well, this is definitely longer, and this is kind of the same thing as a loop, right? So instead of 1,000 times, we're doing this kind of multiplied by 1,000 times 1,000, and we're doing this much longer. So I would probably make the argument that this is going to take 1,000 times longer than the first one. Now, we made the claim that the first one is maybe going to take like a second or less. In reality, it's probably going to take much less than a second, probably on the order of milliseconds. So I would say number 2 would probably take like 1 or 2 seconds, maybe even less or maybe longer, depending on the speed of kind of your computer. Okay, but it's going to be kind of a couple seconds. So the third one is where we start getting into the kind of weirder territory. This one's really arbitrary, right? How long does it take us to go to google.com? Okay, so first of all, like, what does that even mean, right? Like, does it count for me to open up my browser and then wait for it to load and then go to Google and then wait for it to load? Like, or do I just refresh Google and check how long that takes? So let's just see that kind of second scenario, right? Let's keep it super simple. Let's just assume you have your browser ready and you just want to go to google.com. Okay, how long is that going to take you? So I'm going to open up Google Chrome and see how long this might take. So this might be a bit tricky to see depending on kind of the screen size you're using. I'll make sure I can't really increase the size of this over here, but if I reload this page, right, you can see that there's a spinny icon going on over here. And eventually it kind of goes away. So if I reload this page, or if I go here and I press enter again, you can see the spinny icon. It's pretty quick, right? Pretty quick. That I would say is maybe like 1 second, maybe just over 1, depending on kind of how fast my internet happens to be. I happen to have pretty fast internet at home here, so this would really depend on the speed of your network. If you're on a mobile network or kind of somewhere else that has a much kind of lower speed connection, then it's going to take a little bit longer. You might notice this on different pages. Some take longer to load, some are much faster, right? So Google's a pretty kind of stripped down web page. There's not very much going on this page. It's purposely built to be as fast as possible. So I would say like about a second, depending on your network connection though. So I want you to keep that in the back of your mind, right? Now we're starting to get into a bit of a fuzzy area. And this is kind of where promises are really going to start to shine, right? For me, it seems to take maybe a second. If I was kind of on my mobile network and I was in the mountains somewhere, maybe it would take much longer, right? If I was in a place with much faster internet, or I was hardwired into the Google network, for example, maybe this would be less than a second, right? So it's not kind of obvious at the get-go how long this is going to take. And that's really, really the key. So keep that at the back of your mind as we start going through these next examples as well. Okay, so that's Google. The next one, again, is kind of weird. It's like, okay, Nader, like, what is the point of all this? I promise you I'm going to get to a point. So ordering a coffee at a coffee shop, right? How long is that going to take? Now, I'm sure we could come up with even more scenarios here where, you know, it could really be super fast, right? Or it could take almost an eternity sometimes. So maybe like if you have like a self-checkout kiosk, or if you are ordering from your phone for takeout or something, maybe that's a bit faster, right? It's definitely not 1 second, but it's faster. Right? If you kind of have a chat with a barista and it's like maybe a fancier coffee shop and they're taking your time making a latte or something, then that's definitely going to take longer, right? For you to pay, for them to make it, having a chat with the barista, and then them finally being able to deliver the coffee, you putting the lid on it, all that kind of stuff. It takes a little bit of time, right? Maybe it takes 5 minutes. Maybe sometimes even in some coffee shops, it takes longer than that if they're very, very busy. Right? Maybe there's a line around the block and you have to wait for 10 minutes, 20 minutes, right? There's all sorts of factors that come into play when we're talking about kind of more complex systems like this. Okay, so number 4, I don't really know. I would say maybe anywhere from 30 seconds minimum if you're pretty quick with like a mobile order to like an hour if maybe there's a lineup and it's a new coffee shop or something, right? For number 5, driving to the shopping mall, it's a similar scenario, right? How far is the shopping mall away, right? Do we have a lot of traffic on the way to the shopping mall? Are we on a scooter? Are we in a car, right? What's the speed of our kind of vehicle that we're using? All of these things are going to determine how long it takes to get to the shopping mall. Maybe there's like a accident along the way and we have to get diverted and go another direction. Or maybe we get distracted along the way and we never end up going to the shopping mall and it actually never ends up happening, right? All of these different things are factors that we should take into account when kind of thinking about these systems. Now, funnily enough, these might seem kind of like just super random, but actually I would say that these are really good interview questions. Actually, once you start seeing promises and we start dealing with things like networks and front end and back end development, I would love to be able to ask someone this kind of question in an interview and kind of see how their mind thinks when it comes to things like failure cases and like different scenarios that might happen and how to deal with each of them. So definitely not lost on you if you really want to think about this a bit deeper. Now, my favorite one on here, obviously, since I'm also a space nerd, is traveling to Mars. This is definitely kind of also a bit arbitrary. In the best case, I would probably say with our current technology, this might take like 9 months as a one-way trip if you're down for that kind of thing. Using kind of rocket technology. But if you go the longer way, it might take much longer. And that's assuming nothing happens along the way. Maybe in the future, we develop faster technology. We can just shorten that time from 9 months to much less. Maybe we can teleport there in the future and it's instant, right? This is also arbitrary, but the point is we don't kind of get in the rocket and just magically appear in Mars, right? Like that would be great. And maybe in the future that's possible. But for now, that's just not how reality works, right? All of these things here take some indeterminate number of time or amount of time, right? We could say that some of these ones here, for example, we can kind of determine to some degree, but even those are not really determinate, right? Because the speed of your computer makes a huge difference when doing this. In fact, like I would actually make the argument that even these are not as cut and dry, right? Because maybe as you're looping or as you're mapping through these, like the sun has a solar flare and some like a little bit of radiation hits like one of the parts in your computer chip, which happens all the time, things like satellites, and throws off that calculation, and then your computer crashes and it never finishes, right? So this might sound like really pedantic, but I just want to kind of make the case, right, that these things all take time. They might never finish. They might finish very quickly. They might finish very slowly. But they are not things that happen instantly, okay? Just because something happens very, very quickly in a computer does not mean it's instant. And these things over here might take a very long time, and that just increases the amount of things that can happen in between that amount of time to cause issues. So why did I spend so much time talking about things like this that have nothing to do seemingly with promises? Well, let me kind of share a story with you right after I share this next slide. So I want you to keep this in mind as I get into the beautiful set of drawings that I've made to kind of explain how promises work. I have 3 states here listed on the screen. Okay, always keep these 3 at the back of your mind whenever you think of promises. A promise in JavaScript and many other languages can only be in one of these 3 states at any given time. In fact, once it's not in pending, it's permanently either going to be fulfilled or rejected. Okay, so for example, if you think about, let's say, going to google.com, before we get there, while we're loading, we're pending because we haven't actually loaded Google yet. Once we successfully open Google, then it's done. It's loaded. We've fulfilled the promise. If we have an error along the way, or some radiation hits our computer chip and we kind of lose our connection, or there's an interruption in our network, or Google goes down, then it would have been rejected, and we would not have seen google.com, and that would have permanently been the case, the state, for that promise going forward. Okay, once it's in fulfilled or rejected, it's stuck that way, and we'll see this in more detail once we code this out together. Now for the drawings I've been promising you. I want to tell you a story. Okay, to really, really give you a good analogy for how this is going to work when it comes to promises. Now, I have an ice cream shop here, and this has the wonderful name of Sunday Fun Day. So let's imagine that this is you, okay? And like pretty much everyone, hopefully you love ice cream, and if you're lactose intolerant or something like that, let's just pretend that this is ice cream that you can eat, maybe lactose free or something. But let's pretend you love ice cream and you're going to this ice cream shop for maybe a scoop or 2 of ice cream. Okay, so this is you. So I want you to think of kind of promises in this series of steps, because it'll really help cement the idea of how this works when we actually code it out together. Okay, so here's a story. You walk into the store, right? And you look through the ice creams. Right, and you go to kind of the cashier, the person behind the cashier, and you say, "Hey, like I want to order some ice cream." Right, I found my favorite, mint chocolate chip or pistachio or vanilla, and I want to order this ice cream. Okay, so when you do that, I want you to think about this question: what do you kind of get? So when you go to the cashier and you say, "Hey, I want a vanilla ice cream," right? What actually happens in real life? Well, I'll make the case that you kind of pay them, right? Some currency, some money or something, right? Or you give them your card, and then they'll tell you, okay, well, I'm gonna give you kind of this receipt, right? So it's usually not the case that as soon as you pay them, that you just magically an ice cream appears in your hand. right? I mean, maybe in some cases that might be true where they're super fast and doing a whole bunch of things at once. But generally speaking, you will go to the cashier, you'll pay for that item, and then they will give you a receipt. Okay, so we're going to end up in this scenario right here, where we've paid the cashier, we've gotten a receipt. Now, I want you to think about this really deeply for a second. This receipt, what is a receipt? If you really think about it, like how would you explain a receipt to someone, right? I would say that once we've paid for an item and we have the receipt, that receipt is proof that we've paid for that item, right? That's why a lot of stores ask you to bring the receipt if you want a refund or something like that, right? I'll also kind of bring this back to JavaScript and say, technically in this case, since we actually haven't received our ice cream yet, we can also think of this receipt as a promise for an ice cream that we ordered, right? So we ordered that, say, vanilla or mint chocolate chip ice cream, and they didn't give it to us yet, right? They gave us a receipt because we paid for it, right? And now they're gonna go and kind of scoop the ice cream and put it in our favorite cone and then give it to us, right? So we have not received our ice cream yet. Okay, that's the key. We've received a receipt for an ice cream in the future. All right, so once that's happened, what actually happens? Well, we make our way over here maybe, right, to the counter. We kind of pick it out again, and then the cashier will come by and help us out. They'll scoop the ice cream, they'll put it in our favorite cone with sprinkles and all that jazz, and then they'll hopefully give us our ice cream, right? So I'm going to make the case that technically two things can happen at this point, right? Maybe it's the case that that doesn't happen, right? I want you to think of, once we're waiting here for our ice cream to be delivered to us with our receipt in hand, what are two things that could happen? Okay, once you've given that a thought, I want to show you the first thing that can happen, which is the more obvious one, okay? And that's this case. Okay, this is the case where they successfully deliver us our ice cream, right? So it's a vanilla ice cream, and they've put in our, the sprinkles on top, and they've handed it to us, and we're super happy, as you can see, right? Very, very happy. This is the successful case. We have paid for it, we waited for it, and then we got back the actual thing that we wanted, which is the ice cream in this case. Okay, so in the context of promises, this is a successful, what's called fulfilled promise. Okay. Now the other case is this one. Now I couldn't find a sad face in my little drawing program here, so I decided to get creative. And this is me being creative, as you can see with my excellent drawing skills. So this is just a mind-blown, frustrated kind of look, I guess. This is the case where the cashier tells us, hey, Nanner, like you can't have this ice cream, right? Either we ran out of vanilla or mint chocolate chip or whatever it is that we asked for, or maybe something else crazy happened, right? Maybe they just don't like us. Maybe they're just like, you know what, I'm not gonna give it to you. I'm just gonna leave. Like the cashier's just gonna walk out the store and leave us with nothing, right? All sorts of things can happen technically. Maybe, like some kind of a bear comes into the store and just takes all the ice cream and walks out, right? I'm just kind of getting crazy here, but like a crazy amount of things that can happen that can prevent us from getting to our beautiful ice cream in the short amount of time between where we paid for it and where we're actually waiting to get it delivered to us. So in this case, we are not getting the ice cream. So we're sad, we're upset, we have been rejected effectively. Okay, this is the case where there's an error in this process. Even though we paid for it, we are not getting what we wanted because there's some kind of issue, some kind of problem, and this is the rejection case in a promise. Okay, so we think back to those states. When we paid for the ice cream, we were pending, right? Because we were waiting for it. We haven't got it yet, but we've made that transaction and we're pending. Then after we pay for it and we're waiting and we get the ice cream, that's this case right here, then it's fulfilled, right? We're successful, we're good to go, we can kind of leave the store and enjoy our ice cream. And then the other case, which I just demonstrated right now, is a rejected case, right? Which is this one right here, which is we did not actually get the ice cream because of whatever issue ended up happening. Okay, so why am I spending so much time on this, right? Before I show you kind of a bit of code, I just want to really explain why this analogy I would like you to keep at the back of your mind, along with kind of questions like this. Okay, so the reason is that this concept of asynchronous programming with promises is actually quite complex. Okay, once we actually start getting into the code, a lot of bugs end up happening because of kind of a mismatch in our mental model between how this process is different from our regular coding process. Because if you think about how we've been coding up until now, we've been coding in what's called a synchronous fashion, which means that everything is step by step, top to bottom, top to bottom, top to bottom. We have things like loops that take a bit of time, but it'll never be the case that we just magically go from the loop to some other function without telling the code to do that, right? Everything is kind of very readable from top to bottom in a very process-oriented way. But with promises, that breaks that programming philosophy. Okay, with promises, we can have things happen at arbitrary amounts of time, right? Maybe we start something now and then we get the result a second or two later, right? Maybe we never get the result at all. Maybe it takes 10 seconds. Maybe it takes a minute, right? We are no longer really in control, really, of how long things take. And this affects how we actually program our code. So think of this analogy, think of these problems as you're working with promises. It will really help kind of ground your mental model of how promises work, not only in JavaScript, but really in every single language. So I just want to quickly go through this flow diagram. In the context of JavaScript, we kind of have this flow of promises. As I mentioned, we start with pending. If we are successful and we fulfill the promise, then we can use this thing called a then, which I'll explain in a second as we do our promises. And if we reject a promise, then we go into this thing called a catch. We have this optional thing called a finally, which I'll get into later in future videos. But for now, we'll just keep it simple and focus kind of on these states right here: pending, fulfilled, and rejected. And we're going to look at .then and .catch to accomplish those behaviors and actually deal with these promises. So to start, let's look at some code and actually code this out together. Right here, I have some pretty gnarly looking code, but let's go through it kind of one line at a time. Over here in this block, I am constructing this promise object. Okay, you can think of it as constructing that kind of like a receipt flow. Now, a promise is an object that's built into JavaScript that works like this. If you look at the right side of this equal sign, this is how we construct a promise object. We say new promise, very similar to how we looked at maps and sets. And this promise constructor, the function for a promise, it takes a function as an argument. Okay, and this function, very similar to map and filter and reduce and things like that for arrays, it has two different parameters. Okay, traditionally these are called resolve and reject. However, we can call them whatever we want, since as we know with functions, our parameter names don't really matter as long as we use them correctly inside the function body. But I encourage you to call them resolve and reject just so it's super clear what's happening. Resolve and reject are actually both functions that are given to us by JavaScript. So we don't actually have to code these ourselves, but we can use them in order to accomplish certain behavior. Now, inside of this particular promise that I have on the screen, and we're going to code this out in a second, I have this weird thing right here. If you've never seen this before, this is something that's built into most kind of JavaScript runtimes. It's not really part of JavaScript, but we can kind of treat it as part of JavaScript. It's called set timeout. And this is a function that, very similar to promise and other things, takes a function as an argument, and it will execute that function after a certain number of milliseconds, which is the second argument that we pass it, which is 1,000 in this case. So I'm saying, in this case, to execute this function after 1,000 milliseconds or 1 second. Okay, so this promise is going to execute this code after 1 second. That's what set timeout is going to do in this case, and I'll show it to you in code in a sec. So what are we executing? Well, we're calling this resolve function that was given to us, and we're giving it a string, okay, as its argument. So what does that actually mean? And what is the point of this string? We'll get to this shortly, but I just want to show you that this is how we create a promise. I also want to note that it's not always the case that you'll end up creating these promises from scratch like this yourself. Most of the time, we're going to be using other people's promises from their own code and actually kind of consuming them, which we'll see as well. But if you can see how a promise is constructed like this, it really helps kind of form that mental model of like, okay, I can see how this code is working behind the scenes, so I can kind of deal with cases that might arise as a result. So if we log out this promise, which is stored in my receipt, or my receipt is pointing to this promise, this would actually show as a pending promise object, okay? Because at the start, we are in pending. Okay, we start at pending, and then only in the future do we either go to fulfilled or rejected, okay? So in this case, we are saying that maybe we're gonna go to fulfilled, right? We don't really know yet. I'll show you in a second as we code this out. So this is a bit confusing on a slide, so let's actually jump into Visual Studio Code and actually start editing this together. All right, so in VS Code, I'm just gonna create a new file. I'll call this new promise.js. Let's create a promise. I'll call it my promise. And I'm going to create a promise using new promise, just like that. Okay. Just make this a little bit bigger so you can kind of see this. Now, this promise constructor takes a function as its argument. So I'm going to pass it a function just like this, an arrow function in this case. Okay. So this is an empty arrow function. And this arrow function has two arguments given to us. So we're going to give it a resolve and a reject. And these are given to us by JavaScript automatically. And we can name these whatever we want. But again, as I mentioned, I want to name these something that makes sense so it's easy for other people to understand. I'm going to give myself some space in this function. And now we're actually going to code this out. So the goal of this promise is to, in this case, give us a message after 1 second. So as I mentioned, we can use set timeout like this in JavaScript. In most environments, this will work. And we can give this a function as well as a time in milliseconds. So if I give it a function here, in this case it's doing nothing, and 1000 milliseconds, it's going to execute this code, which is nothing right now, after 1000 milliseconds. Okay, and this will work in most environments. So I'm just going to tell it what code to execute. I will just say console.log, and I'll just say, hello, my friend. Okay. Okay. All right, cool. So I'll just make this a bit smaller so I have a bit more room again, and I'll bring up my terminal here. I'll make sure in the right folder I have new promise.js. And now I'm going to execute this and run it. So if I run node and I run new promise.js, okay, interesting. So I'll do that one more time just so we can see kind of what's happening. Node, interesting. Takes a second, right? It takes a second. Okay, so something different is happening here than our normal programs, right? If you really pay attention to this, and I'll just run it a few times as I'm talking, you can see that it takes a second before we actually see the result. And if I increase this to say 2 seconds, right, it'll be a bit more obvious. This is going to kind of hang there for 2 seconds until we get our result, and then the program will end, right? So I want to kind of show you that if I put a console.log here of hello ? Right? I want you to think, right? Before I run this code, what is going to be the order of these console logs? Is it going to be this one and then this one? Or is it going to be this one and then this one? Now, as we learn promises, you're going to get better at noticing these. And it turns out that this is also another really popular interview question, is to actually kind of try to figure out asynchronously which of these codes is going to run first. Okay, and you'll get better at this the more that you practice. So let's take a look at the answer. So I'm going to see hello right away, and then I'm going to see hello, my friend, after 2 seconds. Okay, so look at it one more time. As soon as I run this, I'm going to get hello right away, and then hello, my friend, after 2 seconds. Okay, so this already is kind of odd, right? This kind of breaks kind of what we've been seeing with programming so far. We have this thing here, which appears to be console logging something, right? And then we have a console log after it. But this console log is happening after the console log below it, right? So what is going on? And this is the idea of promises, right? This is what I was mentioning about code running in the future versus running currently right now. So in this case, we are scheduling this code to run in the future. It's not going to run right now, right? Any other code is allowed to run in between now and that future. We are not going to stop JavaScript from running any other code until this is done, right? Because it doesn't make sense. If you think about it, if we were to block our JavaScript program from running any code until this 2 seconds passed and then log this after, that would be a tremendous waste of resources, right? Because if you think about it, we could actually do a lot of things down here, right? We could do lots of things, lots of code, right? We could run a lot of things down here, get a lot of stuff done, be very productive while waiting for this to run in the future, right? We don't really have to wait for this to be done necessarily to execute this code, right? Now there's exceptions to that, which we'll see shortly, but generally that's the premise, right? And this is really the power behind tools such as Node.js and JavaScript, okay? They allow us to schedule these things to run in the future, and we can schedule as many of them as we want, but we can still run code right now while those things are about to happen in the future in the background. All right? So let's kind of build on this a little bit, and I just want to show you what happens if I do this. If I console.log out my promise, and I'll clear this out just so we have a bit more space, you can see that this shows us that this promise is a pending promise. All right, that means that it is in kind of, where is it? This state right here. Okay, so as soon as the promise is created, it's immediately pending. Then in the future, it can either go to fulfilled or it can go to rejected. In this case, it's never ever really going to go to fulfilled because we're not calling resolve. That's how we end up actually fulfilling a promise. Or we can call reject to reject a promise. We'll see that in a second. Okay? But the most important thing to keep in mind here is kind of the schedule that these console logs are running in. Okay? These are going to happen first, like we normally would see in a program. This is going to happen in the future in this case, because it's not going to resolve until 2 seconds later, or it's not going to kind of complete until 2 seconds later. Okay. So that said, I want to show you this next slide here. So in order to fulfill a promise, we need to call the resolve function that was given to us in the promise constructor. Okay, so these two right here, we can actually use these to change the state of our promise to be resolved or rejected. Okay, otherwise it's going to be pending, or sorry, to be fulfilled or rejected. To actually resolve the promise, we can use this function and we can give it anything that we want as an argument as the resolved value. Okay. In order to actually use that resolved value, we can actually use another method on the promise object called .then. Okay. Now this is where things start to get a bit hairy, so I'll make sure to go a bit slow. The .then method only works on promises, okay? And it takes a function as the argument. And very similar to map, filter, and reduce that we saw with arrays, it's going to give us the value that was resolved as its first parameter, okay? So in this case, if I say the parameter is called resolved value, this here's your ice cream is actually going to get put into this resolve value as an argument when the .then is called by resolve in the future. So in this code here, this is resolving after 1 second, with the value of here's your ice cream. So if I have a .then attached to this promise object, which is pending to start, then that resolved value of here's your ice cream is actually going to end up giving passed to us as an argument inside of this function call. And we can make use of it inside of that function. And if we were to log it, for example, we would actually get that value that it was resolved with. So we can basically pass these values and messages from the promise back outside to when they are fulfilled. All right, so I'll show you why this is useful in a second, but let's actually just code it out to see how this might work. So after this console log, I'm going to call a resolve, and I'm going to resolve with here is your ice cream. Okay. So if I run this code right now, I get pretty much no difference, right? I get hello, promise pending, and then hello, my friend. Okay. So what is up with this? Like, why can't we see this being printed out? In order to actually extract the resolved or rejected value, we need to actually use a .then or a .catch on these promises. So the way that we do that is we take our promise object and we can use .then on it. And this .then takes a function, okay? Just like this. We're gonna give it an arrow function in this case. And we can give any name for this parameter, right? So I can say, I'll just call it resolve value to keep it consistent with the slides. Okay, but we can name this whatever we want. And inside of this function, we can use that value. Okay, I can say resolve value. And before I log this resolve value, I just want to say console.log, promise seems to be done. Okay. Now this is where things are going to get really, really hairy, right? And this is why kind of this mental model really, really helps as you're learning this stuff. What is going to be the order of these console logs? I want you to think about that. So what we saw before was that this is going to be printed first, this is going to be printed second, and we're going to get promise pending. Okay. Then once this promise kind of runs after 2 seconds, or this code inside this promise runs after 2 seconds, so this is scheduled to run in the future after 2 seconds, we're going to see hello, my friend being logged out, just like here. But right after that, we're going to resolve the promise, which is going to trigger a .then if we have one attached. Do we have one attached? Yes, we do. We have it right here, right? So then the .then is going to be called with this value as the argument. So resolve value is going to be this string. Then we're going to call this function right here. And this function is going to print out promise seems to be done. And then it's going to console log out here is your ice cream, which is the value that we were passed to this function. Okay, so let's run that and see if that was the case. So we wait 2 seconds and then we get hello, my friend, which is what we see here after 2 seconds. Then promise seems to be done, which is what's happening here, which is the .then. And the final value right here, which is here is your ice cream, which is the resolve value, which is coming from here. Okay. Now, I think this is the part I would encourage you to rewatch a couple times just to make sure you really understand, because this is really the core of promises right here. Okay. We have had something scheduled to run in the future, and we can get values out of that future event that happens and do something with it down here. Okay. Cool. So let's go to kind of the next thing that we need to look at, which is what happens if a promise is rejected. So I'm going to take that same example before, but instead of resolving it, I'm going to reject it, right? And I'm going to say it was rejected with sorry, we're out of ice cream. Okay. So let's see how this works. With a reject, we can't use a .then. Well, technically we can, but the easier syntax to use is a .catch. Okay, so think of catch as used for handling errors and rejections, then is being used for handling successful promises and them being fulfilled. The syntax is the exact same. For reject, we can pass it a value to reject with, but instead of using .then, we can use .catch. We give it a function, we get that value, and then we can do something with that value. Okay, so the key here is we're not using resolve anymore. We're using reject after 1 second, or in our case with our code after 2 seconds. I'm going to change this. Actually, I'm going to comment this out, I should probably say. I'm going to say I'm going to reject this code I'm going to say, sorry, no ice cream for you, right? After 2 seconds. I'm actually not going to add a then, or sorry, a catch block, and I'm going to see what happens. Okay, so if I run this, let's see. And kind of an explosion of crazy looking stuff. Okay, we get some kind of error. So the error seems to be kind of right here where we have an unhandled promise rejection error. Okay, so that seems like it kind of makes sense, right? We have a rejection of this promise, but we're not really doing anything with that rejection, right? We're not handling it. We were only kind of being optimistic here and handling the case where it was resolved. We were not handling the case where it was rejected. So in order to handle the case where it's rejected, what we can do is we can chain a dot catch onto this promise. And we have to do it this way because we cannot do this. Oops, let me undo this here. We cannot do this because of the way that kind of promises work, and we'll get into this in future videos. But effectively, what this is saying is that this is going to run kind of separately of this chain. So if we didn't have our catch here, this promise would try to fulfill, and it would fail, and then there would be no catch attached to this promise right here that we were working with, and we would still get this error. Okay, so what we want to do is we want to make sure that if we're doing it this way, we kind of what's called promise chain these, and we have a dot then happen first, and then we have a dot catch after. So I'll kind of do this like this, just so it's a bit easier to read, right? We have the promise, we're doing the then clause, and then we can do the catch clause. So in the catch clause, I'm going to add a function in here, and I'm going to say, you know, there was some kind of error, for example, then I'm going to console.log that error. Okay, so just like that. So in this case, for this promise, if it's successful, we're going to go here. If it's not successful, we're going to go here. Be careful where your dots are and kind of your brackets are. You'll get used to it as you go. Just keep in mind what I said earlier. You want to have this working and chained onto the same promise. It works slightly differently if you try to split these up onto 2 different promises. Okay, so just to recap before we run this, what we had before was an unhandled promise rejection error. And what we want to see is hopefully this error goes away. Okay, so if I rerun this code, let's see. And there we go, right? So in this case, we seem to be getting the sorry, no ice cream for you. And that's the message that's being passed to us here, which is very similar to the resolve case, but in this case, it's being passed to us here in the catch block, right? What you see is we're not getting this line 11 on my screen, which is promise seems to be done because it wasn't successfully resolved. It was rejected. Okay. Hopefully that makes sense. What I want to show you really quick is kind of this chain, right? This is exactly what we built. And this is a nice visual of kind of what's happening. When we resolve a promise, we kind of get this value shoved here into this dot then clause. If we were to actually return a promise from our other promise, we would actually be able to chain these promises together. This is a concept that I'd like to get to in future videos because I don't want this video to run too long. But just so I can show you how this might work, if we were to actually return something from this promise, like return, say, yo, right? We would actually get a promise returned to us from this function. So anything in a dot then or dot catch or finally clause will return a promise. Okay, so if I run this right now and I try to resolve this, let me comment out my reject and comment in my resolve really quick, just so I can show you how this chain might work. We can chain multiple of these promises together. If I run this, you can see that the promise seems to be done. Here's your ice cream, right? Which is all I'm getting is right here. So we seem to be ignoring this value. Okay, we're not actually seeing yo being printed out anywhere. And the reason is because this is really another promise. And if you think about it, how do we use the resolved value of another promise? Well, we use a dot then, right? So if I do another dot then, this is where things get really crazy, right? And I kind of console log this out. Let's just say I get the another value here. and I console.log out this another value, okay, just like that. And I clear out my console and I run this. Let's see what happens here. So I'm actually going to see yo being printed out, right? So what's happening is this is resolving with here's your ice cream, which is coming here. And then we log that out. And then this is resolving with yo, which is looking for another dot then, which is attached, which we have here, which is being logged out right here, right? So we can keep chaining these together. And as we start using technologies like fetch and working with APIs, this concept of chaining these promises is going to become very, very handy, because a lot of promises end up kind of using this function in order to kind of pass things down to each other in a very kind of neat way. However, this code can look pretty gnarly pretty quickly, as you can already see. So there are strategies we can use, which we'll get into in future videos as well after we're done promises, called async await, which is a newer syntax to make this much less scary and ugly looking and much easier to reason through. However, at the fundamental level, it's still working with these behind the scenes. So we need to make sure that we really understand how promises work. Okay, so if this last part was a bit confusing, definitely rewatch it a couple times, but don't worry about it too much, because we're going to see it come up a few times where we're going to have more practice with it. Just know that we can kind of chain these promises together, just like we chained the dot catch into this promise chain. And a promise chain looks just like this, just to recap. Okay, so to really quick kind of show you what's going to happen here before we finish off this video, I'm going to comment back in reject. Okay, so now this looks kind of weird, right? What is going to happen here, right? If I look at resolve, that's going to be resolved, but then I call reject right away. So are we going to also go to the dot catch? What do you think? So if I run this code, let's see, fingers crossed, and we get the resolved case. We never end up getting the sorry, no ice cream for you, right? And this is really the key part of promises. Once a promise is pending, it can only go to one of two states. It can either be resolved or it can be rejected, right? It can either be fulfilled or rejected. Once we fulfill it or resolve it, it's permanently stuck in that case forever, right? It's never going to be rejected, right? So whatever happens first in the case of fulfilling or resolving a promise or rejecting a promise, it's going to be stuck in that state going forward. So this is actually going to have no effect at all on our promise. Okay, so that's very, very important to keep in mind. And just to show you kind of how this will work, what I'll do is right after logging out this resolve value is I want to console log out this promise, which is my promise. Okay, I just want to show you the state change that happens inside of the dot then, which is what happens after the promise is resolved. We can see that the promise is pending when we log it down here, which is before it gets resolved after 2 seconds. But after we resolve it, what is it going to be? Let's take a look. So if I run this after 2 seconds, it looks like we have this thing, which is no longer a pending promise. It is actually a fulfilled promise with its fulfilled value. Okay, if we do the same thing down here, where I console.log out my promise inside the error case, the dot catch case. Let me clear this console out. I'm going to make sure I comment out my resolve so that my rejection happens, and I rerun this code. What we'll see is kind of the same thing, but we get a little helpful hint that this promise is now in a rejected state, not in a resolved state. I don't actually know why it doesn't say the resolved state in Node.js for kind of a little hint there, but the previous one was resolved, and now it's rejected after we do the reject call. Okay, so this video definitely is quite a lot packed in. I would probably encourage you to kind of go through this a couple of times just so that you know kind of these different states and how these logs are being are kind of being logged out. Get into the habit of tracing kind of where these logs are happening, right? If I put a log over here versus if I put a log over here versus in the catch block versus outside over here before the promise kind of resolves, like what's going to happen first, what's going to happen next, what's going to be the order of promises, what happens if I reject before I resolve, what happens if the resolve, there's never a reject, right? What's going to get logged out, what's not going to get logged out. Try all those cases. What we're going to do in the next video together is actually do that together through a bunch of exercises. I have quite a few exercises planned for that one where we're really going to kind of tear this down and really try to understand it fundamentally. So if you want more practice, definitely join me in that video next. As well, in future videos after we're done that, I'm going to go over kind of another concept which I hinted at in this video called async await, which is a newer JavaScript concept where we can actually kind of get rid of this .then and .catch syntax and work with code a bit more in the way that we're used to working, where it kind of reads a bit nicer from top to bottom, and we're not really trying to, jump from here to over here to over here to over here. However, before you actually get to that, it's really, really important that you understand this concept, because everything that's promise-based in JavaScript, which is most things these days, is built on this concept, the fundamental kind of vanilla promise behind the scenes. So if you found this video helpful and valuable, I'd love it if you could like the video and subscribe to the channel. As well, I'd love to hear in the comments what you thought of the video, of my drawings, if that concept helped, if you have any other analogies that you want to share with anyone else, or if you had any weird things happen while you're trying to run this code. The code that we're writing now in this kind of second half of the series is going to get kind of a bit more kind of meaty and more complex, because we're kind of combining these concepts. And asynchronous programming is always going to be a tricky concept, no matter what language you're building it in. There's always kind of a mental mind warping you have to do to think about, okay, what's going to happen first, what's going to happen second, etc. And there's countless bugs that can happen as a result of this that happen all the time as people are building their apps, whether it's on the front end or the back end or wherever it happens to be. So that said, I can't wait to get to the exercises to practice this concept more together. I'll see you in that video.